Hello everyone, welcome back to the data science program. In this video we will be covering Python tuples. In the previous video we have covered a Python list, and both are almost similar. There is one big difference, and that is the mutability part. If you have covered the previous video, if you know Python list, this video is going to be like a smooth video for you guys because tuples and list both are almost similar. So I'll take you guys to the collab notebook where we'll see these topics one by one. So we'll start off with the definition part. So tuple is a collection of objects and that is separated by commas. In some ways tuples is similar to a Python list in terms of indexing, nested objects and repetition, but the main difference between both of them is Python tuple is immutable, unlike Python list which is mutable. So there is one big difference, and that is the mutability part. Apart from that, you don't have to worry too much about these two topics because both are almost similar to each other. If you know Python list, this is going to be like a piece of cake for you guys. Tuples, there is only one big difference, and I'll teach you guys how to deal with that. So here is an example of a tuple. In Python list we have a opening square and closing square bracket. Similarly we have this structure here. Only difference is you have to use this round opening and closing bracket, unlike Python list, and inside that you can use different data types, homogeneous, heterogeneous, just like Python list. So we'll start off with the characteristics first. One by one we'll see there are three characteristics mainly, and we'll see these characteristics one by one. So the first characteristics says that Python tuple are ordered. So order matters in Python list. So suppose we have a variable, we have a tuple here 1, 2, 3, 4, 5, and we have one more tuple, let's say A2, and we have same items inside A2 as A1, but only difference is this time we'll use this item on different index positions. So let's say we are using 2, 1, 4, 3, and then we have 5. So we have the same items which is present in A1, but these are on different index position. So order are different for both of them. So now if we check whether A1 is equal to A2, we should get false as the result, because its order matters in Python tuple. See, both are not same because both are present on the different index position. If I check, suppose we have b1 equals to let's say 1, 2, 3, 4, and similarly we have one more tuple b2, and this time we'll use same items and on the same index positions. So we are using 1, 2, 3, and 4. So, and I have to use this equal to sign. We have same items and all these items are present on the same index position. And now if we check whether b1 is equal to b2, we should get true as the output. We will get true as the output because in order matters, and this time we are using the same items and on the same order. All these items are present on the same orders. So that's about this first characteristics, and now we will see the second one. It says Python tuple are immutable, and that's one of the big difference if you compare it with Python list. Python list are mutable, you can do changes to a Python list, but in tuple you cannot do changes. I'll show you guys one example here. Suppose we have c1 equals to 1, 2, 3, 4, and if we try to change this one with this with the value of 10, so I will replace this item on the 0th index, which is 1, and I will keep the value as 10. And now if I run the cell, we will get error here, and I'll show you guys the error message. Tuple object does not support item assignment, so you cannot assign a value to an index position. That means you cannot do changes to a tuple. So that was the second part, second characteristics. Now we will see the third one, and the third one says that it allows duplicate values, so you can use duplicate values inside a tuple. So we will use c2 equals to, and I will use duplicate values this time, 1 2 3 and 4, and now I will use one more 2. So we have duplicate value, we have one here and we have one here, we have 2 and we have 2. That means we are using duplicate values. And now if you try to print c2, you will get the output as 1 2 3, and then according to this order. That means you can use duplicate values inside that. And now we'll see the we have covered 3 characteristics. The first one was ordered, and second characteristics was mutability, and the third one was we can use duplicate items inside a tuple. Now we will see the different ways in which you can create a tuple. There are many ways you can create a tuple, and we'll see these topics one by one. So the first way to create a tuple is empty tuple. Similar to list, the way we used to create empty list, we can use same syntax we will use to create a empty tuple. So instead of that opening square and closing square bracket, we will use the round bracket, opening and closing one, and you just have to print d1, and we will get the empty tuple as the output. See, we are getting the empty tuple as the output. And now we will see creating a tuple with a single item. And there is a difference in list. You can create a Python list using a single item, but this if you are doing the same thing in tuple, the syntax is going to be a bit different. You cannot use the normal syntax. I will show you guys. Suppose we have d1 equals to, and we have a single item inside this tuple, let's say 2. And if you try to print d2, you will get the integer as the output, but you won't get the tuple. Okay, it's d1. Instead of this, we have d1. And now if you run the cell, we will get 2 as the output, which means we are getting an integer as the output, but the output should be a tuple. So this is not the correct syntax. You have to use a different syntax. So instead of this syntax, we will use d1 equals to and 2, and then after that item after giving that value, you have to use that comma, and now you have to print d1. And if you run the cell, we will get this 2 inside this tuple. So this is the correct syntax how you can create a tuple with a single item. And now we will see the homogeneous, where we will be creating a tuple, and we will be using the same will be using the items with the same data type. So we are creating d2 equals to, and we are using same data types. Initially we are using integer, all the integers values, and we are printing d2, and we'll get all the integers as the output because we have given all the integers as the values. And we will see one more example. In homogeneous, you can use any data type. I will add one more cell. This time we will use d3 equals to, this time we will use string, and hello, and then we will use cast. And now I will print d3. We have used only strings inside this, so it's an example of a homogeneous tuple. And now I will print d3. If I print d3, now we will get this as the output. And one more example, we will take complex as the example now, and d4, let's say d4 equals to, and inside this we will use let's say we are using only floats or complex number 5 plus 6j, then 4 plus 2j. We have used two complex number, and now we will print d4. Now if you try to print d4, we will get these inside a tuple. See, we are getting 5 plus 6j, which is the first complex value, and 4 plus 2j, which is the second complex value. So these are the example of homogeneous tuple. We have used different data types inside a tuple. Now we will see this. I will delete this cell, and we will see the heterogeneous example. Heterogeneous means you can use different data types inside this tuple, and we will use, let's say we have e1 equals to, we have tuple, we have an integer here, let's say 22, and then we have a float 3.09, and then we have a complex number 5 plus 6j, and then we have let's say we have a string my name. So we have different data types, and I will now print e1, and now if you print e1, we will get output we will get these different data types as the output, because we have provided the values as different data types. And now we will see 2D tuple. So 2D tuple means there is a tuple inside the outer tuple. So let's say we have e2, and we have a outer tuple. Inside that we have 1, 2, 3, 4, and after that we have one more tuple. Inside that, suppose we have 7, 8, 9. So we have two tuple, outer tuple and inner tuple. We have a tuple inside a tuple, that means it's a 2D tuple. So you have to check how many brackets are opening and how many brackets are closing. So we have 2 here, so it's a 2D example. And we will print e2, and we are getting the 2D tuple as the output. The last example is by using the type conversion. So let's say we have e3, and inside that we have what you can do is you can convert any a string data type to a tuple by using this syntax. You have to write tuple, and then you have to use this bracket, and inside that bracket we are giving this as the input. And now I will print e3. So what it will do, it will create a tuple, and it will store all these string values one by one inside the tuple. So you can create you can convert a data type into a tuple by using the type conversion method. And now we will see the accessing item from a tuple. We have different ways of accessing items from a tuple. We have 2 ways, indexing and slicing. Inside indexing we can use positive and negative indexing, and we can use step size as well. And in the slicing part also we have positive slicing with positive indexing and slicing with negative indexing, and we can use a step size, or we can use we can do that. We can convert a string, and we can reverse that string. So we will see these examples one by one. So first we will see a positive indexing. Let's say we have e4, and we have a tuple here 1, 2, 3, 4, 5. So we have these items inside this tuple, and we will try to fetch this 3 by using the positive indexing. So positive indexing means it should go from left side to the right side. So on the left hand side, on the first item, the first item is present on the 0th index. So we have to fetch 3. That means we have to move to the right direction. Right now we are in the 0th index, 2 is on the first index, and 3 is on the second index position. So I have to we have to write e4 of 3 is present on the second index position. And what I will do is I will simply print, and I will print e4 at the second index position. And now if I run the cell, we are getting 3 as the output. Similarly, you can fetch 5 as well, or any point, any number inside this tuple. I will show you guys one more example. I will print e4 at the index position 4, and we will get 5 as the output. 5. now we will use the negative indexing. Negative indexing means you have to move from the right hand side to the left hand side, and the first index position starts with -1. So suppose we have e5 equals to 1 comma 2 comma 3 comma 4 comma 5. I will simply copy this because I have to use this several times. And now we have to, last time we have fetched this 3 by using the positive indexing. This time we will fetch it with the by using the negative indexing. So negative indexing starts from this point. So this is 5 is present on the -1 index position, 4 is on the -2 index position, and 3 is present on the -3 index position. So I will simply print e5 of -3, and now I will run the cell and we will get 3 as the output. See, we are getting 3 as the output. If you want to fetch this 4, you simply have to write -2. If you want to fetch this one, you have to type -1 -2 -3 -4 -5. So you have to use -5 as the index position. So that's about this negative indexing. And suppose if you try to provide any index position which is not valid, so here we have only items present only till the 4th index position. So if I simply try to print e5 of, let's say, 10th index position, we don't have any item present on this 10th index position. We don't have a 10th index position, so we should get error here. So we will get error, and I will show you guys the example. Index tuple index out of range. So we don't have any index position 10 here. So now we will see slicing, and we will use positive indexing and negative indexing for that slicing part. So suppose we have the same example here, and suppose we want to fetch 2, 3 and 4. If you want to fetch more than one item, you have to use slicing. If you want to fetch only single item, you have to use indexing. So now we will use slicing with positive indexing, and we have to fetch 2, 3 and 4, let's say. So 2 starts from the first index position, second index position and third index position. So I will print e5 of we have to fetch 2, 3 and 4. That means first index to first, second and third. So we have to write 4 because last one is not included. So now if I print, we will get 2, 3 and 4 as the output. So you can use step size. I will simply paste, and I will add few more items, 6, 7, 8. And now suppose we want to print from 2 to 8, let's say, or 2 to 7. So first index position, second index position, third index position, fourth index position, fifth index position and sixth index position, till sixth index position. So e5 of from second index position till sixth index position. So I have to write 7 because last one is not included. And now if I run the cell, we are getting 3, 4, 5, 6, 7. But suppose we want to skip one item between these. Suppose we want to print 3 and we want to skip 4. We want to print 5 and we want to skip 4. For that you have to give step size, and step size is going to be 2 here. And now if I try to print, see, we are skipping one items. We are skipping 2 and then we are printing 3. Then we are skipping 4, we are printing 5. We are skipping 6 and we are printing. You can give this step size according to your convenience. You can give 3 as the step size here, or if you have more items you can give more value to this step size. And now we will see with the negative indexing, slicing with negative indexing. So I will simply paste and I will add 6, 7, 8, and now we will try to fetch 8, 7 and 6 with negative indexing. I will print e5 of, so this starts from -1. We have to go till, we want to go till this 6 point, -1, -2, -3. So from -1 we want to go till -2, -3, so -4. I have to write -4. And now if I run the cell, oh, you have to remember one thing here. The first, if you are converting this by using the negative slicing, the first number has to be the small one, so you have to write -4 here, and this has to be -1. And now if I print, see, we are getting 5, 6, 7. Suppose we want to fetch 5, 6, 7, 8, we have to write -5 here, -5. See, we are getting 4, 5, 6, 7. Now we will see one 2D example, fetching an item by in a 2D tuple. So let's say we have f, let's say we have f, and we have 1, 2, 3, 4, 5, and then we have one more tuple, 6, 7, 8. And now if suppose we want to fetch this 6, so how to approach? So I will write print and then f of, first you have to check this is on the first index position, this is on the second index position, third index position, fourth index position, this is on the 0th index position, 1, 2, 3, 4, fourth, and this is on the 5th index position. This complete tuple is on the 5th index position. So 5th index position, and from this 5th index position I have to fetch this 6, which is on the 0th index position, so I have to write 0. And now if I print, I will get 6 as the output. Suppose if you want to fetch this part, this 7, so instead of this 0 you have to provide 1, and now we will get 7 as the output. So by using this syntax you can fetch an item, in a 2D tuple. And now we will see the reversing, we will see how to reverse a tuple, and same way we used to do in list, we can reverse a tuple here. Suppose we have this and we want to reverse this tuple, so simply you have to write print and e5 of, and you have to use this syntax ::1 ::1, and by using this syntax we can simply reverse the tuple. See, we have reversed this tuple 5, 4, 3, 2, 1. And now we'll see editing. Since tuples are immutable, you cannot do changes, so you cannot edit an item inside a tuple, but still we will see an example how we will get the error if we try to edit. Let's say we have this e5, and if we try to edit this first item, and if we try to replace this one by 10, so let's say e5 of 0th index equals to, let's say, 10, and now if I run the cell we will get error because tuple object does not support item assignment, so you cannot do changes to a tuple, so it will show you the error. Now we will see adding items not possible. Okay, we have covered this part. So now if we will see this adding items in list. We have a few functions like append, insert, and we have one more, extend. We have used these 3 functions to for adding an item inside a list, but in tuple we don't have such functionalities. We don't have any functionalities for adding an item, so you cannot add any item inside a tuple. And deleting is also not possible. If we want to delete a particular item from a tuple, that's not possible. You can delete the complete tuple. I'll show you guys the example. So let's say we have e6 equals to, let's say we have 1, 2, 3, and if I print e6, and after that if I delete, you have to use this del keyword, and if I delete this, and now if I run the cell, and no, after this suppose if I print e6, and now if I run the cell, see we are getting error. What I will do is I will simply remove this, and I will see initially we are getting the output, but after that if I delete e6, and after that if I print, initially we are able to print, but if after deleting, if you try to print e6, we will get error. See, name6 is not defined because we have already deleted e6. So now we will see the operations on a tuple. It's almost similar to a list. In list also we have used addition and multiplication as the arithmetic operations. In list also we have covered loops and membership operator in and not in. So we will see arithmetic operation first, and first we will see the addition one. So let's say we have t1, let's say we have t1 1 comma 2 comma 3, and similarly we have t2 equals to, let's say we have 4 comma 5 comma 6. We have these two, and now if we try to add this t1 with t2, so what it will do is it will basically merge, it will basically concatenate these two tuples. See, it has created a single tuple and it has stored these values inside this tuple. Now we will see product. Suppose we have t1. Okay, I will simply copy this. I will simply copy, and I will paste it over here. I will paste it over here, and this also I will paste. Copy, and then I will paste, and now we will do product, or we only need one tuple here, so we use only t1. So we will do t1 into let's say 2. See, we are getting 1 2 3 1, and then again 1 2 3. If you change this value and if you keep this value as 3, you will get these values 3 times. Similarly, like list, it's almost similar. Till now we have studied whatever we have studied in list. We have not studied anything different. We have covered all these parts in a list. If you have watched the previous video which was on list, this is going to be like a piece of cake for you guys. So now we will see loops. Suppose we have this t2, we will use for I in t2. You can use loops. For I in t2 we will print I, and we will get 4 5 6 as the output. So you can use loops, and then we have this membership operations. We can perform this membership operations on tuples. First we will see in operator, and then we will see a not in operator. We will use the same. I will add few more, let's say 7 8, and we will check whether we have two in this tuple or not. So 2 in t2, and I will run. We will get false as the output because we don't have 2 inside this tuple. We will check one more value which is already present. We will use 4 in t2, and we are getting true as the output because 4 is present inside this tuple. Now we will see not in operator. We will check whether 4 not in t2, and we will get false as the output because 4 is present inside this. So that's about this membership operators, and now we will see a few functions. We have less functions compared to Python list. In Python list we have more number of functions compared to Python tuple. So we will see first common ones which are common in all the data types. we have these functions which we have studied in strings and which we have studied in list. This sum is common in list and tuple, and these are common in all the data types. So we will use this tuple, and we will try to print t2 len of t2, let's say sum of t2, and we will get 5 plus 4 plus 6, which is 15 as the output. So you have to use this syntax sum of t2 and you will get the output. Similarly, you can print min of t2, and you will get 4 because 4 is the minimum here. Similarly, we can use print max of t2, and if we print, we will get 6 as the output because 6 is the maximum. And then we have sorted print, which sorts the tuple in ascending order. Print sorted and then sorted t2, so it will sort. We have these items already in sorted order. We will add one more cell here, and what we will do is you can reverse this in descending order by using this syntax. Print sorted of t2, you have to write reverse equals to true, and now if you print, you will get 654 as the output because we have reversed these items in descending order. We have sorted these items in descending order, and then we have len, and we will use the same print, and then we have len. It will tell you the length of the tuple. We will use t2. We will get 3 as the output because we have 3 items. Then we have a count. Count tells you the number of occurrence of an item. Suppose we want to check, I will add few more items. Let's say we have 6 and then 7 and then 8. Suppose we want to, and I will copy this, and suppose we want to count how many times we have 8 here. So what I will do is I will write t2 dot count, and I want to count the number of occurrence. We have 8 here. We have 8 only. Suppose we have 6 three times here. So if I try to count 6, and if I run the cell, we will get 3 as the output because we have 6 3 times. Similarly, you can check for other. Let's say we want to check for 7. If you want to check 7, how many times we have 7, we are getting 1 because we have only 1 7 here. I will keep it to 6 only, and we will get 3 as the output. Then if you want to check the index position of a particular item, you can do that by using the index function. I will paste, and then we will check t2 dot index, and we want to check the index position of 5. Let's say index of 5 t2 dot index of 5. It will tell you the index position of 5. So we have 1 here. 4 is present on the 0th index and 5 is present on the first index. I will add one more cell just to show you guys. If you have a duplicate item, we have items. We have 6 3 times. So now if you try to check the index position of 6, it will give you the first occurrence as the output. So t2 dot index, and we will provide 6 as the input, and we will get 3 as the we will get the this index position as the output, because this is the first occurrence of 6. So 0, 1 and 2. So this is the first occurrence of 6, that's why we are getting 2 as the output. Then we have a topic here, tuple unpacking. There is a stylish way of representing. Suppose you have a comma b comma c. Okay, I have to remove this, and you have this syntax 1 comma 2 comma 3. And now if you try to print a comma b comma c, we will get 1 2 3 as the output. This is the stylish way of representing these tuples. So what we are doing here, we are simply unpacking this part. So what in the next example, what we will see is we will see when we give too many values to unpack, which means here we will have more number of items to unpack, and that will give us the error here. Suppose we have only 2 items here, A and B, and we want to unpack, let's say 4 items, 1 2 3 4. And now if I try to print A comma B, we will get the error as too many values to unpack, expected to. We have 2 variables here, so we should unpack only 2 values, but we have 4 here. That's why we are getting the error here. Then we will see swapping. In other programming languages, you need a third variable to swap numbers, but in Python you can, in tuples you can do that very easily. Suppose we have a equals to let's say 10, and then we have b equals to 20, and we want to swap a comma b equals to b comma a. And now if I print a comma b, initially we have the a value as 10, so it should give us a is equal to 20 as the value, as the output. See, we are getting a equals to 20. We have actually swapped these numbers, and you don't actually need the third variable to swap. So now we will see this part. So suppose you have too many values, like suppose you have a comma b comma, let's say others, and then you have 1 comma 2 comma 4 comma 5 comma 6 comma 7. You have these values. So what will happen here is, this first we will give this first to this A, we will give this second to this B, and rest of the items will go into the others. So now if I try to print A comma B, and then if I try to print others, and so we should get 1 and 2. A and B values are 1 and 2, and then rest the others value we have 4 5 6 7. And now we will see zip. So zip operates on the values of 2 iterable item wise. So zip example we will see. Suppose we have 2 tuples here, let's say t1 equals to 1 comma 2 comma 3, t2 equals to 4 comma 5 comma 6. So what you can do is, you can simply use zip of t1 comma t2. We have already used t1 and t2, so I will change this to t11 and t12 and t12. So what we are doing is, we are simply zipping t11 and t12. This should give us the zip object. So what you can do here is, you can simply use tuple of zip. and now if you do this, we will get all these values inside this tuple. So what it has done is it has combined this 1 and 4 inside a tuple, 2 and 5 inside this tuple, 3 and 6 inside this tuple. What you can do, you can use list comprehension, and you can add these values. Like I will add one more cell here. What you can do is you can simply use I plus j for I in let's say zip of t11 and j in t12, and now if you run, actually we should use zip of t11. For I, what we have to use here is for I comma j in zip of t11 comma t12, and now if you try to print, see we are getting what we have done here is we have added 1 and 4 which has given us the output as 5, 2 and 5 which has given us the output as 7. Sorry for the wrong syntax, this is the correct syntax. You can use I plus j. This is the expression and item in iterable. We have combined this, we have added these two numbers, and these are the outputs. Now we will see a few differences between list and tuple. The first one is the syntax. I will simply write comments only. List, we use this opening bracket, and then in tuple we have this syntax. Mutability, we have list are mutable and tuples are immutable / unchangeable. So, and then we have functionalities. As you can see, we have studied only few functionalities here in tuples, so we have less number of functionalities in tuple compared to list. So I will simply write list has more functionalities than tuples. Error, list are okay to write list are more error prone than tuples. And speed wise tuples are faster. All the data types which are immutable are generally faster than mutable data types. So tuples are faster than lists. And memory wise, list occupies more space than tuples. So that's about this session. Tuples are almost similar to list. If you know list, tuples are almost similar. There is one big difference, mutability part. Tuples are immutable, you cannot do changes to a tuple. And that's about this session. Thank you for watching.